Hello everyone, welcome to this video. So we're going to go through this chapter 20 kinematics. This is one of all the homework questions that I feel that is worth explaining. So I'm going to go through all the questions to give you a little hand. So let's start with question 9. You notice that I've underlined all the important points in this question. You see this phrase, t seconds after passing O. Very important, you keep seeing this again and again. What it says is, when I pass O, then I start counting, which in other words is, that means t, when t equals 0, you're actually at O, which means s also equals 0 lah. Okay, so that's what the hidden message is. So let's go through the rest of the question. So here, acceleration when it comes instantaneously to rest. So this phrase again means when the velocity is 0. Because when you're at rest, you're not moving, so v equals 0. And then when it is next at O, that means when it's s equals 0 again, because it's next at O. So you're going to imagine there's going to be two answers. One is probably t equals 0, and then t equals something else. So that's the answer I want. Okay, so distance traveled for the first 3 seconds. Then it just first 3 seconds. Okay, so let's go through the answer for the first question. So for the first question, they ask for acceleration when v is equal to 0. So you see, they gave us this equation first, and then from there I'm going to get the rest because it's just differentiation. So if I differentiate s, I get v. I differentiate v, I get a. So I'm just differentiating. This is easy. So when you say when it's at rest, so that means I'm going to let v equal 0 when it's instantaneously at rest. And I solve, I get t equal to t equal minus 2. So minus 2 must be rejected because t cannot be negative. Doesn't make sense, right? After I find the t, I'm going to sub this t into the acceleration formula, which is this one. So I sub t equal to, answer is negative 12. Okay, so for the next part, see the question asks for velocity when it is next at 0, so s equal to 0. So in the working, you'll see that I sub s equal 0. So this is the one. So because s is here, s equals 0, I factorize out the t and this one, so equals 0. This equals 0. I get plus minus square root 12. So this is the moment I want. And then they ask for velocity, so I'm going to sub this t equal root 12 into v, and then I do, the answer is negative 24. Okay, so next, the last part, they ask for the distance traveled for the first 3 seconds. So if you look at the whole story, I started at O, and then you realize that when I put v equals 0, t is equal to 2. That means at t equal to 2, it actually turns back, See, that's why I draw at t equal to 2, it turns back. Because when when the v equals 0, that means it's turning back. It's stopping and it's changing direction, so it turns back. So when I sub t equal to 2 into s, I get 16. That means this whole distance from t equals 0 to t equal 2 is 16. And then when I sub t equal to 3, I get 9. So that means at t equal to 3, it turns back until here, t equal to 3, and then this distance from O, remember it's always from O, this is 9. So by the law of common sense, this is 7, because this is 16, right? So the whole distance traveled is 16 plus 7. That's why the answer is 16 plus 7. Okay, so now let's look at question 10. So for question 10, again, see, notice this phrase again. T seconds is the time after leaving O, which means again t and O matches. So that means at t equals 0, you are at O. That means s is 0. So same thing. If you look with the questions, I want what? The non-zero of s when p comes instantaneously to rest. Again, this means v equals 0. I want the distance traveled in the third second, which means between 2 and 3. That means the second and third second in between how much I traveled. And then when velocity, I want to find the velocity when acceleration is negative 12. So when a equal to negative 12. So same thing. I'm going to start with the first part. The non-zero value of s when instantaneously at rest. So v equals 0. So let's start with this. So since they give me the s, I have to find v myself. So from s to v, I'm going to differentiate, and then say it's at rest, right? So v equals 0. I let v equal 0, and I'm just going to solve blah 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 blah. I get t equals 0, t equal 3, t equal negative 3. So negative 3 is rejected because it cannot be negative. T equals 0 is rejected because I don't want it to be the starting point. So t equal 3 is the answer that I want. So after this, at t equal to 3, I want to find the non-zero value of s. So that's why I sub t equal 3 into s. So s is here, I'm going to sub 3, answer is 81. So that's the answer. Okay, so next part, I need to find the distance traveled in the third second. So between 2 and 3, I need to find how far we have traveled. So what I do is, you can see that I drew a small thing here. So at 2, this is certain distance. At 3, this is certain distance. So again, I need to find this question mark in the middle. So what I do is I sub t equal to into s. The answer is 56. So that means at this point here is 56. And then I'm going to sub 3. Actually 3 don't need because 3 already done already. So it's 81. So when t equal to 3, the whole thing is 81. So again, by law of common sense, this part must be this minus this. Okay, so it's this, and the answer is 25. So let's look at the third part. It says the velocity of p when the acceleration is negative 12. So again, I'm going to let before that, I realize I don't have acceleration. So I need to, from here, I'm going to differentiate v. A is going to be this, and then I let a equal to negative 12. So I let a equal to negative 12, blah 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 blah. I get negative 2 or 2. So obviously negative 2 cannot reject. So t equal to 2. And then I want v at this moment. So I need to find the v formula, which is over here. I'm going to sub 2. So after I sub 2, the answer is 40. Okay, so next question. I think 17 is the more difficult one. So for 17, you notice that this one, underline, is slightly a bit different from the rest. It says t is the time after motion has begun. That means the t starts counting when I start moving. Now, does it mean that you start moving when you're at O? Never say, right? Never say. Usually it's not. In fact, once you look at the s formula, you know that this is displacement. If you sub t equals 0, it becomes 0, 0, 0, 40. So this is a clear sign that the particle didn't start from O. Okay, so just be careful. And same thing again, velocity is 0, so v equals 0. This one, acceleration, has a magnitude. So magnitude is a different word you have not seen before. Magnitude means the number itself. So it's either 9 or minus 9, also counts. Okay, so you need to solve for these two numbers later. And then for the third part, average speed. So average speed is normal. You just find for the first 2 seconds how much you traveled, then you divide by the time. And then for the total distance traveled, 6 seconds. So again, you need to see where the answer is later. So let's get the answer out. Okay, so the first part of the question would be find the p when the velocity is 0. And again, it's very suspicious. This is distances. Well, that means you know that maybe there's a few points we're looking at. So first of all, let's start with the s, and I'm going to differentiate. I get v, And since I saw the acceleration somewhere in the question, here, I might as well just also differentiate again to get A, get it out of the way first. So when we first start, they say let V equal 0 because it's instantaneously 0. So I let it equal 0. I can divide throughout by 3. From here, I do the cross method. I get two answers, 1 and 5. And that's why they say distances, because there's two answers. Okay, so from here, between this 1 and 5, I'm going to sub 1 into S, I get 47. I'm going to sub 5 into S, I get 15. So that's the answer for the first part of the question. So the second part says that I want the t when acceleration has magnitude of 9. That means 9 or negative 9, both I want. So in the working, you do exactly that. You let A equal 9, let A equal negative 9. You solve 4.5, solve 1.5. No problem. Okay, so next. So the hard part begins now. The average speed of P during the first 2 seconds. Now, the questions will always drop some hint for you. So the hint they drop for you here is right here. You notice that when you let V equal 0, one of the answer is 1. And then now I want the first 2 seconds. That means before the first 2 seconds, the guy already turned already. So there's some trick here. So what I do is I need to draw the whole thing out. Just now we established that when we start t equals 0, it's already 40 meters away. Okay, because the S formula has a t plus 40. So the default is 40. So I draw like that. At t equals 0, I'm already 40 away. So when t equal to 1, you see, happens to be here, t equal to 1, I'm at 47. So at t equal to 1, the whole thing is 47. And then also when I solve for instances at rest, t equal to 1 also, that means at this point I'm turning. So what I do is I need to find t equal to 2. So I sub t equal to 2 into S, I get 42. That means at this point, the distance from this point to O is 42. And then I want average speed of the first 2 seconds. So that means from t equals 0, I move 7. From 1 to 2, I move another 5. So total, I've moved 12. See? 12. Over 2 seconds, that's why the answer is 6. Okay, so this is pretty tricky. So next. Next question will be total distance traveled in the first 6 seconds. So this one also pretty complicated. Okay, so first 6 seconds, you notice that again, when V equals 0, I turn at 1, I turn at 5 again, and now I want the first 6 seconds, so pretty complicated. I'm turning twice. So let's try to draw this thing big again. So the story goes like this. At 0, I'm 40 away. After that, I travel 1 second, 7. I turn, I go all the way until 5. So what is this distance? I'm not sure, I need to check. So at t equal to 5, you notice I've actually already found the answer. See, t equal to 5 into S, it is 15. So at the 5 second mark, I am 15 away. So by the law of common sense, if this is 47, this is 15, then this must be 32. And at 5, I turn. So what is this distance? I need to check. So what I do is I sub 6 into the distance. Blah blah blah, I get 22. So that means at this point, after I turn at t equal to 6, this whole distance is 22. And since I know this is 15, this is 7. So how much did I travel? From 0 to 1, 7. From 1 to 5, another 32. From 5 to 6, 7. That's why it is 7 here. 32 plus another 7. Total 46. Okay, so let's go for the last question. Question 18. Okay, so for question 18, again, passes a fixed point on the line. I pass t seconds after passing. So again, this is the standard s equals 0, t equals 0. But this one is a bit different because at this point when I pass, I already have speed. Okay, so although I start counting at O, I'm already starting to run before I even hit here. Just that when I cross the O, I start counting and I'm already running. Okay, so that's one of those things. After that, you see I want distance before it comes to a rest. So I need to find t equals 0 and it first comes to a rest. So the first very suspicious. That means there's some other t. So I'm going to take the smallest, but I say first. Okay, so before it comes to rest. So before this t, this value of t, I need to find the distance. So next thing, total time it takes to return to starting point. So that means when s equal to 0 again. And then the minimum velocity. So this is our maximum minima. I want the minimum. Okay, so let's start. So first thing is I need to find when it comes to a rest. So they only gave us acceleration. So to get v, I need to integrate this. That's why it's integrate 6t minus 8. Integrate. I get this plus c. So when you integrate, you have a problem because you have plus c, which means I need to find, I need to know a point where t equals something, v equals something. And from the question, so a combination of this. So this tells me that t equals 0, s equals 0. And when s equals 0, v is equal to 4. So what we do is we sub when t equals 0, v equal to 4. So 0, 0, and c is 4. So I conclude that the v is this full formula. And after that, from the v to get s, again I differentiate, I integrate this, blah blah blah. Again is something plus c. And again I need a point where I know t, I know s. So I know that t is equal to 0 when s is equal to 0. So I sub t equals 0, s equals 0, t is 0. So the full s formula is this one. After that I start doing. So right now I already forgot the question. So it first comes to a rest. So v equals 0. So once I have v equals 0, this equals 0, I can factorize. I solve, I get 2/3 and 2. I reject this because it says first comes to a rest. So I'm going to take the smaller value. Okay, and I want to find what? The distance. So from here, I sub this into the distance formula, blah blah blah, I get the answer. Okay, after that, the next part of the question, total time it takes to return to the starting point. So that means s equals 0. So from here, I let s equals 0, so this whole thing equals 0. Again, t, I'm going to factorize t, left a quadratic, t equals 0 from here. I'm going to solve this, I get this square, so t equal to 2. So from here, I need to find the total time it returns. So this is already the time, so this is the answer already. Okay, so for the third part, I want the minimum velocity. So this is our maximum minima. So let's start with the v formula because I want to know the velocity, right? Minimum velocity. So this is v. If I differentiate, I get this, which is actually the acceleration. So this is the one. And I let this dv dt equal 0. So this equals 0. I solve, t equal 4/3. And at this point, the velocity is a minimum. So I'm going to sub this point into v. Sub in, I get negative 4/3. So this will be the 4 questions that I think most people have been asking me for the kinematics homework. Hope you find this video useful. Thank you and bye bye.